Let us look at some examples and applications of total internal reflection. Formation of mirage and the sparkling of a diamond is due to total internal reflection. The illusion of the presence of water on a hot summer day at a distance is known as mirage. The images of the nearby objects give the impression that there is a pool of water, but this in reality is an optical illusion. During a hot summer day, the layer of air nearest to the surface of the earth is hottest. And as we move up the ground, we come across layers of air with decreasing temperature. As a result, the refractive index of different layers of air increases as we move up. And hence, layers of the hot air near the Earth's surface are optically rarer than the layers of the cold air a little above it. Due to this, rays from the nearby objects which are propagating towards the Earth's surface refract and bend away from the normal. At some point, the angle of incidence exceeds the critical angle and the rays undergo total internal reflection. An observer is able to see the image and get the impression of a mirage. Another example of total internal reflection is the sparkling of diamond. Diamond has a high refractive index of 2.42 and the critical angle for the diamond air interface is 24.4 degrees. Diamonds are cut in such a way that most of the light rays entering the diamond undergo total internal reflection many times before they exit. This gives diamonds their bright sparkle. Total internal reflection is made use of in some technological applications also. In many optical instruments, prisms are used to deflect and redirect the light without loss of intensity. Right-angled prisms are most commonly used for such applications. A right-angled prism, whose critical angle is less than 45 degrees, can be used to deflect light at a right angle. Light incident normally on side AB passes without deviation and incident on side AC at an angle 45 degrees. Since the angle of incidence is greater than the critical angle, the light is totally internally reflected and is deviated from its original path by 90 degrees. If light is incident normally on the side AC, it travels straight and hits side AB. Then, light is internally reflected twice at surface AB and BC and leaves the prism with a deviation of 180 degrees. In this case, the image of an object gets inverted. The same prism can also be used to obtain an inverted image of an object without changing its size. Another application of total internal reflection is in optical fibers. Optical fiber is usually fabricated from glass or quartz and consists of core and cladding. The refractive index of the core material is a little higher than that of cladding material. When light is allowed to enter the core in such a way that the angle of incidence at the core cladding interface is greater than the critical angle, it will undergo successive total internal reflections all along its path in the core. Since the loss of energy is quite small in case of total internal reflection, Light can be transmitted over longer distances through optical fiber with least loss of energy. This is made use of in case of optical fiber cables used for long-distance transmission of light signals. In communication systems, optical fiber cables are used to transmit video and audio signals at the speed of light. In such cases, the electrical signals are first converted to light signals and then they are transmitted through optical fiber cables. Optical fiber has applications in medicine also. It is used by doctors to illuminate and view the internal organs such as the esophagus, stomach, intestines, etc. to get back their images and if necessary to even carry a laser beam to the relevant spot.